8.1, covering simplifying algebraic expressions. What we have here is 4 terms here, and I listed off an example of this first term. I know it has definitions down for each one of them, but a constant, an example of a constant is like 23 or 14 or 8.4. All those are examples of constants. The biggest thing is the term does not have a variable. We also have a term. A term can be a number, such as 23 is a term. You could have a variable, such as x. X is a term. Or it could be a product of numbers and variables. Remember, a product means multiplication, so it can be something as simple as 34x. Okay? All those are examples of terms. Coefficient. Coefficient is a numerical factor of a term that contains a variable. So it is basically the number out in front of the variable. And I'll give you an example here on the next slide. Like terms are terms that contain the same variables with the same power. These two are examples of terms. Okay, 14x is a term. X is also a term. Big thing that I want to point out here is that 14 in this term is considered the coefficient. Okay, your coefficient is the number out in front of the variable. X down below, X is a term, and it really does have a coefficient here. The coefficient of this X is 1. So it does have a coefficient. If there's nothing out in front of the variable, you can always put a 1, and that's basically what we're trying to get at there. So in our examples here, example 1, it says identify the terms, identify the like terms, identify your coefficients, and identify the constants in this basically problem here, this expression. We have 3x minus 5 plus 2x minus x. In this problem, we're going to go ahead and identify the terms. Well, the terms are 3x, negative 5, positive 2x, and a negative x. Those are our terms. The like terms in this problem would be 3x, 2x, and negative x. Okay? Notice they all have the same variable, and all the variables have the same exponent. They really all have an exponent of 1. So all of those are like terms. You can combine them. Our coefficients in the problem. Well, the coefficients in the problem, if you look up here, are, remember, numbers that are out in front of the variable. So if we look back up to the above problem in blue there, 3x, well, the coefficient is 3. 2x, the coefficient is 2. And then we have this negative x, remember, really has a coefficient, and that coefficient is negative 1. Remember, coefficient is the number out in front of the variable. And last we have is the constant. Okay, the constant in this problem, remember, as stated before, a constant is a term without a variable. And there's only one up here that has a term without a variable, and that is this negative 5 here. So negative 5 is our constant. In example 2, we're going to go ahead and do the same thing. List off our terms. Our like terms are our coefficients and our constants. In the first thing here, our terms, well, the terms would give us 6x, negative 2, x, and negative 4x. Big thing is when you're writing out your terms, make sure you include the sign. So this 6x is positive. Why we have a positive 6x here. This is negative 2. We have the negative 2 there. Positive x, negative 4x, negative 4x. So a big thing is make sure that you include the correct sign. Your like terms in this example. Well, our like terms, as mentioned before, are terms that contain the same variables to the same power. So our like terms would be 6x, which is positive, x, which is positive, and negative 4x. If you think about it, you could actually steal the like term piece from the terms above. The coefficients. Our coefficients in this problem are the numbers out in front of the variables. So actually we can steal our coefficients from our like terms. Coefficients, well, the coefficient of 6x is 6. The coefficient of x is 1. And the coefficient of negative 4x is negative 4. Last piece here, constant. A constant is again a term without a variable. If you look above from that original problem, there is only one term without a variable. That is this term right there, and that is negative 2. Last example here for this concept. First thing we're going to go ahead is find out our terms again. Well, our terms are 9y, negative 4, negative 11y, and positive 7. Those are our terms. Our like terms. Difference from this piece in comparison to the first two problems is that this actually has a couple sets of like terms. So that being said, like term is 9y and negative 11y. Have the same variable raised to the same exponent. So we have 9y and negative 11y. Those are like terms. We also have another set of like terms. Negative 4 and 7 are like terms. You can add those together. Both those terms don't have a variable. Coefficients. Remember, our coefficients are the numbers in front of the variables. Well, I can only use this setup here of like terms because those have variables. So the coefficients would be 9 and negative 11. The constants are terms without variables, and that would be negative 4 and 7. The whole purpose of finding like terms and knowing what they are is basically being able to simplify expressions here. You need to simplify the expression 6z plus z minus 2 minus 8z plus 2. One thing that you can go ahead and do in the problem right away that might help you out is put the 1 in front of a z there, because you're going to have to add that together. That's really 1z. Now, we need to combine like terms. Well, here's my like terms, and it might be helpful for you to go ahead and actually reorganize everything. So what I would do is I would take my 6z plus my 1z, and then I continue on my problem. Well, I'm not going to put a negative 2 in there because that's not a like term. However, negative 8z is a like term, so I'm going to say minus 8z. Now I can go ahead and combine those, and I can figure out what this would be here, and I would have 6z plus 1z would give me 7z. Drop down my 8z. I have 7z take away 8z, and I get negative 1z. Last piece, I have to go ahead and combine my like terms here. Well, I have a negative 2 and a positive 2. So down below this, I'm going to go negative 2 plus 2. The reason why I'm adding 2 because it's a positive 2. I get 0. So these are the two that I basically would combine together, and I get negative 1z. I don't need to put plus 0 or minus 0 because when you add 0, you don't get anything. So your answer in this problem is negative 1z. Example 5, simplify my expression again. I'm going to go ahead and combine the like terms. I have a 7x. Negative 2 is not with it, but negative 7x is, so minus 7x. Those are my like terms there. My next group of like terms that I would have would be negative 2 and a positive 6, so I have negative 2 plus 6, and I can go ahead and I figure these out. 7 take away 7 is going to give us 0. So 7x take away 7x is 0. Down below I have negative 2 plus 6. Well, negative 2 plus 6 is 4. When I put them together, I wind up with 4. Okay. Again, I don't need to put the plus 0 in there for that term because when you add 0, you don't gain anything. So my answer in 5 is 4. Next example, simplify the expression 2g minus 3g plus 11 minus 8g. Again, combine my like terms. So I have 2g. My other like term would be negative 8g, so minus 8g. My other like terms that I have is negative 3, so I'm going to go ahead and write down negative 3. And another way you could do this, instead of doing above and below, you can actually put it together. So I could maybe reorganize things and say negative 3 here, and then I could say plus 11 because that's a like term. And then you could go ahead and actually just kind of work down your paper here. You have 2g take away 8g. Well, 2 take away 8 is negative 6g. Then we have negative 3 plus 11. Well, negative 3 plus 11 is a positive 8. So I would say plus 8. And this is actually your expression right here. Your answer is negative 6g plus 8. Okay, you have to put that plus sign there. This is an expression. This will conclude our lesson on 8.1 simplifying algebraic expressions.